this is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 6-7 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to identify geometric sequences. So first I'm going to start with the definition. All right. A geometric sequence is a series of terms separated by a common ratio. All right, so again, a geometric sequence is a series of terms separated by a common ratio. There shouldn't be an N on that, good Lord. So what we mean by that is to determine the next value in the sequence, you should be able to multiply by the same number over and over and over and over again. So the way that we figure out whether something's a geometric sequence is we actually start by dividing each term by the term before it. So 12 divided by 4 is 3. 36 divided by 12 is 3. 108 divided by 36 is 3. 24 divided by 108, you guessed it, it's 3. So that common ratio here is 3. So that means that this is a geometric sequence. Now in Algebra 2, they actually change how they describe our geometric sequence. All right, in this box that's down here, this is the Algebra 1 definition. They actually show it in Algebra 2 as a piecewise function. All right, so with the piecewise function, to say what our initial term is when n equals 1, you just go ahead and you put that first value. So this is like stating your initial term, like we used to, but they put it in the form of a piecewise function here. Now for any term that's not the first term, so every term after that, we're following this pattern. So we take r, so our common ratio in this case is 3, and it's multiplied, they use a dot in ours, there we go, so they multiply it times a sub n minus 1. Now remember, this n minus 1, this is not like it's a, this is not part of like a variable or a number. You're not going to, you're not going to take an exponentiate to get rid of it. You're not doing anything weird with that n minus 1. That is simply saying the term before this term. So like if I'm reading this, to find this term, if it's the first term, you use 4. To find this term, you take the previous term and times it by 3 for every other term. Okay, that's kind of what it's saying here. So now for part B is asking us to tell if we have a geometric sequence or not, and then to write the recursive formula. So let's go ahead, I'm going to take out my calculator, and I'm doing the same trick that I did last time. All right, I'm dividing the term by the one before it. So if I do 9.6 divided by 12, I get 0.8. If I do 7.68 and divide it by 9.6, I also get 0.8. I'm going to go ahead and do one more. So I'm going to do 6.144 divided by 7.68. I also got 0.8. All right, so when I divided each term by the term before it, I get 0.8 for each of those. So because that value that it's jumping by is the same every single time, this is a geometric sequence. So now I need to go ahead and write the equation for it. So I say a sub n is equal to, ooh, that's a hideous curly bracket, but there it is, So I start with what my a sub 1 is. So when n is 1, my initial term is 12. And then for this bottom part, I take my common ratio, which is 0.8, times a, oops, make sure that's a good size a. It's not letting me control Z, I don't know why. So 0.8 times a sub n minus 1. And that's for every n bigger than 1. Alright, so now let's do it on the try it. So again, with our try it, I'm going to start by dividing each term by the one before it. I don't like writing so much, so I'm actually just going to draw my arrows like I did on the first one. Pardon me for my laziness. So if I do 1.45 divided by 1.22, I get 0.1 or 1.1188. That number. Now that number goes on for forever, if you notice. So like, you kind of want to look at it and double check things. Now when I did this second jump, 1.68 divided by 1.45, I got 1.1586. I'm going to do one last jump, but I think that this is not geometric already, right? Because it's supposed to be the same every single time. So my last hop, I got 1.136. So this is not geometric. So we could stop there. We don't have to do anything with it. Now I have the feeling this next one is geometric. I haven't actually done it, but check it out. Do you see how it goes 5? So it has 1 digit, 2 digits, 3 digits, 4 digits, and it goes negative, positive, negative, positive. So just kind of those hints on there are kind of telling me that this is probably geometric. All right. So when I divide out my first hop, I got negative 0.5. So now I'm going to do it again. So negative 3.75 divided by 0.75. I got another negative 0.5. And one more time just to make sure. Sometimes they'll make the first two have the pattern and then the last one doesn't. So it's always good just to do a few of them. So here our pattern, we do definitely have a geometric sequence. So to write out our formula, I'm going to put a sub n equals curly bracket. And remember our two constraints here are when n equals 1, you just put your initial term. And when n is greater than 1, you're going to put your common ratio times a sub n minus 1. So there we have it, guys. That is how to identify a geometric sequence and to write the formula for it. Until next time.